Good morning, good afternoon, good evening, ladies and gentlemen. It's a great pleasure to me to join this webinar and talk today about my favorite subject, mycotoxins and oxidative stress. I have been working with antioxidants for the last 40 years, and about 20 years were also associated with mycotoxins. And today it's a good opportunity to share with you a recent finding. So usually I start with this slide just for you to understand that we are living in this dangerous world of free radicals, and those radicals are produced in nature, and we need some kind of umbrella, which we call antioxidant protection. We means our chicken, our pigs, our cows, everybody needs this kind of umbrella. When we're talking about oxidative stress, we need to talk about free radicals. What are free radicals? They are activated molecules of oxygens, which actually can damage all types of biological molecules. And there are internal and external sources of free radicals in biological systems. And among internal sources, the mitochondria are considered to be major source of free radicals. Mitochondria, which are responsible for energy production, but energy production never been 100% efficient, and up to 3% of oxygen can escape from electron transport chain, and they become free radicals. There are also phagocyte cells in the body which are producing free radicals as a weapon to kill pathogens. For them, free radical production is a way to deal with pathogens. There are also some other processes associated with free radical production, as well as external sources of free radical production. And if you look at this slide, what I would like to show you here, that we have antioxidant defense system in the body, which is dealing with these reactive oxygen species or free radicals. And here you can also see mycotoxins as one major source, exogenous source of promotion of free radical production. And what also here important to mention that the physiological level of these free radicals are important for immune defense, for cell signaling, and many other functions in the body. However, the overproduction of free radicals, it's a damaging effect. And at this slide, I would like to underline once more that free radicals damage lipids, they damage DNA, they damage proteins. In fact, free radicals can damage all types of biological molecules. And what is important to remember that the oxidative stress as a result of this balance between antioxidant protection and free radical production is a major cause or major molecular mechanism or major stresses in poultry and animal production. And if you look at this slide, I just summarized main stresses in poultry production, including environmental stresses, technological stresses, nutritional stresses, internal stresses. And here, mycotoxins are considered to be major nutritional stresses which are causing a lot of problems. And you already participated in 3 previous meetings related to mycotoxins, where the negative consequences of mycotoxin contamination have been explained. So when we're talking about mycotoxins, we are talking about silent killers, invisible thieves, unavoidable contaminants, natural toxicants. All these names have been given to a group of fungal metabolites called mycotoxins, and their negative effect on animal production are incalculable. And if we look at this slide, this is the most recent one, 2020, which is summarized the research in the area of mycotoxins. You can see here that 22% of research related to aflatoxin, 18% to DON, 16% zearalenone, 15% ochratoxins, and combined mycotoxins studies are related to 20% of total research. And then here you can also see that the research related to mycotoxins in chicken in total comprise about 14% and pig 23%. So almost 40% of all research related to mycotoxins is associated with their effect on pigs and chicken. And as I mentioned already, that mycotoxins have detrimental effect on poultry, on pigs, on cows, on any farm animals. And the major mycotoxins of concerns include aflatoxin, ochratoxin, fumonisin, T2 and DON, and zearalenone. And today, the major point of the presentation is to consider more in detail molecular mechanisms of mycotoxin action with specific references to oxidative stress. And this paper came 2008, so it's already 13 years old. At that time, we suggested that actually mycotoxins are involved in creations of oxidative stress, and the inhibition of protein synthesis, DNA and RNA synthesis, and damages to DNA. This related to ochratoxin, T2 toxin, aflatoxin, and other mycotoxins. Most of mycotoxins impose lipid peroxidation and structure membrane damages. Then we have also induction of the program cell death, which is called apoptosis. Practically all mycotoxins are involved. Then we're talking about transcription factors and gene expression regulation, where mycotoxins are involved. And finally, maintain disturbances of redox balance in the gut and redox balance in cells are considered as a major consequences of mycotoxin toxicity. So as a result, we have immunosuppression, hepatotoxicity, nephrotoxicity, neurotoxicity, genotoxicity. And in this case, we are talking about increased mortality, poor feed conversion ratio, poor growth rate, feed refusal, decreased fertility, and hatchability. More recent paper, 2018, confirms the same. This is a review paper, which again showing that aflatoxin, fumonisin, ochratoxin, zearalenone, DON, nivalenol, T2 toxin, they impose oxidative stress. They affect mitochondria, the major source of free radical production. They impose lipid peroxidation. They impose apoptosis, and they also affect or stimulate inflammatory response. Therefore, the pro-oxidant properties of mycotoxins are well established. And this most recent review, which came this year, actually showing that the major mycotoxins, including aflatoxin, ochratoxin, zearalenone, fumonisin, T2, HT2, and DON, they are produced by various fungus, and we are talking about Aspergillus, Penicillium, and Fusarium as three major genera involved in mycotoxin production. And you can see here in various food and feed materials, those mycotoxins can be found. And more specifically, if we look at the molecular mechanism of mycotoxin action, which was characterized in this most recent paper, you can see that the major research in poultry were done with broilers. Aflatoxin, ochratoxin, HT2, and T2 toxin were studied. And here you can see different doses of mycotoxins were used. As the oxidative stress indications, the malonedaldehyde, final product of lipid peroxidation, was used, as well as a concentration of glutathione, major antioxidants, and total antioxidant potential. And what they showed very clearly that most antioxidant enzyme activity were decreased due to mycotoxin contamination. This means that the oxidative stress was imposed. If we look at the same paper on the pig side, Again, you can see here, DON, zearalenone, aflatoxin, fumonisin, they also were used in different doses. Similar oxidative stress parameters were studied, including MDA, glutathione, total antioxidant activity, and they were compromised. And most importantly, again, antioxidant activity or antioxidant enzyme activity were down, like catalase, superoxide dismutase, glutathione peroxidase. These are enzymes which are responsible for antioxidant protection, and decreased their activity is related to oxidative stress. And here is also interesting that pro-inflammatory cytokines are increased. And what about ruminants? Yes, look here, goats, sheep, lamb, cows. Again, the same mycotoxins were tested, various levels of mycotoxins. And similar to monogastric animals, again, malondialdehyde goes up, total antioxidant activity goes down, glutathione as a major cellular antioxidant goes down, and similar to previous studies, the antioxidant enzyme activities goes down. So what is the conclusion? The conclusion is that for all animal species, including poultry, pigs, and ruminant animals, mycotoxins are the problem. Mycotoxins impose oxidative stress, and this oxidative stress is mainly related to disturbances of antioxidant enzyme activity. And this paper, which came 2018, is very interesting in a way. They look at the effect of mycotoxins on the mitochondria. As I mentioned, that mitochondria are a major source of free radical production. And if the mycotoxins can actually compromise function of mitochondria, more free radicals will be produced. And here again, you can see aflatoxin, DON, fumonisin, ochratoxin, T2 toxin, zearalenone, and they actually were tested in various model systems, and it was very clearly showed mitochondrial dysfunction due to mycotoxin contamination. So this is one of the possible mechanisms of toxic effect of mycotoxins affecting mitochondria. By affecting mitochondria, free radical production is increased, antioxidant defenses are compromised, and we are talking about oxidative stress. And most recent papers actually more and more attention paid to two transcription factors. These are specific factors which activate genes. So one transcription factor called NRF2, this transcription factor is responsible for synthesis or activation of synthesis more than 200 of different molecules. Most of them are antioxidants. And aflatoxin, DON, ochratoxin, zearalenone, they affect the expression of this transcription factor, and this effect is dose and exposure dependent, in the way that low doses and short exposure usually activate NRF2, which means at the beginning the body can try to protect itself from a toxic effect of mycotoxins, while higher doses and longer exposure inhibited NRF2 expression. And another transcription factor called NF-kappa B, and this factor is very important because it is responsive for synthesis of pro-inflammatory cytokines. And pro-inflammatory cytokines impose inflammation in the gut, in other tissues. And you can see here data on the effect of DON and other mycotoxins, zearalenone, on the expression of this NF-kappa B. Look at this paper, in particular, it's 2010 paper, and what is shown here is that NF-kappa B expression increased almost 6 times. So in this case, DON can substantially increase the expression of this transcription factor. more pro-inflammatory cytokines are synthesized, and this explains why dawn is so damaging on the gut. Now, effect of mycotoxins on NF-kappa B expression is condition dependent. Depending on type of mycotoxin, dose, duration of exposure, they can activate or inhibit NF-kappa B. And most importantly, there is a balance between these two transcription factors, and this balance is very much determined redox balance in the cell. Therefore, what are consequences of redox balance disturbances by mycotoxins? I mentioned already lipid and protein oxidation. By the way, more and more attention today is paid to protein oxidation, because lipid oxidation, that's something described many years ago. But in recent years, more attention is paid to protein oxidation as a major cause of negative effect of mycotoxins. Apoptosis, which is a programmed cell death, leaky gut and microbiota disturbances, immunosuppressions, damages to healthy tissues, including liver, decreased productive and reproductive performance. And this few papers just to confirm the negative effect of mycotoxins on apoptosis. So mycotoxins, including fumonisin, T2 toxin, and the other fusarium mycotoxins, they easily impose a programmed cell death, which is called apoptosis. And here, one of the paper, and you can see here the T2 toxin increased the activity of caspase-2. This is a specific enzyme responsible for activation of apoptosis. You can see increase in 4 times, 8 times, 12 times. So the activation of apoptosis is very high. One more point, and again, one of the recent paper considering compromised intestinal barrier induced by mycotoxins. So mycotoxins can actually compromise microbiota in the gut, compromise chemical barrier, physical barrier, and immunological barrier in the gut. And that's why mycotoxins very often are associated with various diseases, because the protective effect of the gut is compromised. So when we're talking about healthy gut, we are talking about digestion and absorption, protective barrier, immunity, and balanced microbiota. You can see here normal villi, which are responsive for absorption of nutrients, and these are damaged villi, which could be due to mycotoxins. Do not expect good absorption and good conversion, feed conversion ratio in this case. So free radicals in the gut produced by mitochondria, phagocytes, and various enzymes. And today the actual topic, redox balance in the gut, is a very fashionable one. You can see plenty of reviews in a recent couple of years. And redox balance in microbiota, another topic helping to explain how mycotoxin can affect their health. In particular, mycotoxin can compromise microbiota. And in general terms, if we look here, the syndrome of malabsorption, that's something which is considered to be a common for aflatoxicosis, T2 toxicosis, ochratoxicosis, and this is a syndrome of malabsorption is a result of damages to the gut. So what we have here, we have mycotoxins in the feed, stimulation of lipid and protein oxidation in intestine, oxidative stress and damages to enterocytes, nutrient absorption decrease, antioxidant system is compromised. At the same time, mycotoxins are absorbed, delivered to target tissues and metabolized, and oxidative stress is imposed. So we have detrimental consequences for health. And generally speaking, antioxidants actually can help to deal with these problems. And they can help with gut protection, with liver protection, and immunity maintenance. Therefore, the whole idea is that previous first part of my presentation proves the point that mycotoxins in the diet can actually impose oxidative stress, which means there is a disbalance between free radical production and antioxidant defenses. On one side, mycotoxins increase free radical production, for example, by damaging mitochondria. On the other side, they decrease antioxidant defenses due to decreased activity of antioxidant enzymes. And this is related to few transcription factors, including NRF2, which is responsive for synthesis more than 200 of different antioxidants, and NF-kappa B, the specific transcription factor responsible for inflammation. And let's now, on the second part of presentation, let's look at nutritional antioxidants and protective strategy against mycotoxins. We need to remember that mycotoxins are very damaging. Even if you use some mycotoxin binders, you will never be able to bind 100% of mycotoxins. Those which are escaping binding, they are coming to the liver to be detoxified, and the detoxification in the liver causing oxidative stress and damages to the liver. So we need liver protection. On the other side, DON is detoxified in the gut, and gut microbiota also can be damaged due to mycotoxin contamination, and we need to maintain healthy gut. So when we're talking about antioxidant protection, we need to remember that all antioxidants in the body are working together as a team. We call vitamin E headquarters of antioxidant defense, carotenoids communicating services of antioxidant defense, flavonoids and polyphenolic antioxidant police. We are talking about vitamin C and special forces, selenium chief executive antioxidant defense, and here we are talking about Ministry of Defense, which is gene expression and synthesis of various antioxidant enzymes. So when we're talking about nutritional modulation of antioxidant system, we can consider selenium, vitamin E, vitamin C, polyphenolics, and other nutrients which actually can affect antioxidant systems. And by improving antioxidant defenses, they can help to deal with mycotoxin contamination. So I will start from selenium, because it's my favorite subject, and I have been working with selenium for the last 20 years. Today, we know that selenium is a part of 25 selenoproteins. Those selenoproteins are synthesized in the body in response to stress. And at this slide, you can clearly see that more than half from those 25 selenoproteins are involved in the antioxidant defense and signaling. And now we are talking about dietary selenium, which can affect antioxidant defense. This is our review 2019. And in this case, we are talking about breeder, egg, embryo, day-old chick, postnatal chicks. They are protected due to dietary selenium supplementation. If we look at the balance between NF-kappa B and NRF2 in the gut, you can see that mycotoxins, pathogens, and various stresses can impose oxidative stress and dysbiosis. And in this case, NF-kappa B and NRF2 can be affected. In this case, you can see the NF-kappa B is increased, so the synthesis of pro-inflammatory cytokines is increased, and the NRF2 is decreased, which means that antioxidant defenses are decreased. So if we look further, we will be looking at inflammation, apoptosis, immunosuppression, gut structure damages. Now, what's happened if we have optimal selenium status? So optimal selenium status will help selenoprotein expression. So there will be 25 selenoproteins synthesized. Then we have redox balance regulation, improvement of antioxidant protection. And this antioxidant protection will affect or prevent this oxidative stress imposed by mycotoxins. Then we have effect on prevention of activation of NF-kappa B, which means prevention of inflammation and improvement of antioxidant defenses. And we also have maintenance of commensal microbiota. As a result, we have activation of NRF2, activation of vita genes and decreased activity on FKB. And finally, maintaining redox balance, gut structure, immunocompetence, and gut health. So here, this selenium is taken as just as an example. So in general terms, the antioxidants in the gut can help to maintain these transcription factors in optimal activity, can help to maintain integrity of the gut, and this will help with first antioxidant defenses, and secondly, prevent the actually penetration of pathogens through the gut. And here, the review of 2018, and using this review, we can show how the system works. So we have oxidative stress imposed by mycotoxins. The disruption of epithelial barrier is taking place. Bacteria penetrate this barrier. As a result, the dendritic cells and macrophages will be activated. Macrophages started to produce reactive oxygen species, which free radicals, and they disturb redox balance. As a result, you can see mitochondrial dysfunction, which means that free radical production will be increased even more. And what we have, finally, we have leaky gut. Leaky gut means that the barrier is disrupted and the situation is very difficult. And in this case, we can talk, for example, about syndrome of malabsorption. So on the right side, look what selenium can do. Selenium can affect the prostaglandin synthesis and activation of various transcription factors, which actually prevent activation of this NF-kappa-B, which is responsive for inflammation. So the pro-inflammatory cytokines goes down, anti-inflammatory goes up. We are talking about additional synthesis of selenoproteins. We are talking about additional synthesis of antioxidant enzymes like superoxide dismutase and catalase. And what is happening here? We are talking about redox balance reestablishment and inflammation resolution. So this means that inflammation is taken under the control. And in this case, we are talking about maintenance of the gut structure and antioxidant defenses in the gut will keep healthy gut and prevent those damages caused by mycotoxins. So now, when we're talking about selenium, we need to remember that there are different sources of selenium, and there is an inorganic selenium, which is its first generation of supplements, which came in many years ago. And in this case, this sodium selenite is used in many commercial premises, but the efficiency is low. Second generation of supplement includes seleno yeast and pure selenomethionine, and they have some problems like selenomethionine proportion in seleno yeast only 60–70%, and we have also some problem with stability issues, pure selenomethionine. So finally, the third generation of supplements came on the market, which is hydroxyselenomethionine, helping solving selenium problems and helping to maintain optimal antioxidant defenses, and this can help with mycotoxins. Okay, that was a selenium. However, the most important antioxidant and most studied antioxidant in biological systems is vitamin E. So vitamin E is an antioxidant which is located in cellular membranes, and vitamin E is preventing damages to those membranes. And if you look at our review 2019, you can see that vitamin E has protective effect for breeders and cockerels, for semen, for egg yolk, for embryo, and for newly hatched chick. And you can see here, vitamin E increase antioxidant defenses not only by increasing vitamin E itself, but also by activating superoxide dismutase, glutathione peroxidase catalase. You remember from my previous slide that this enzyme activity was actually decreased due to mycotoxin contamination. So in this case, by using vitamin E, we can reestablish antioxidant defenses in stress conditions. Do we have any evidence related to mycotoxins? Yes. If you look at this publication 2008, it's an effect of T2 toxin and DON on DNA damages. So you can see here, DON and T2 toxin impose DNA damages, and by adding vitamin E, you can decrease those damages. And if we look more specifically in the review paper 2018, which actually look at the protective effect of vitamin E against mycotoxins, we are talking about aflatoxin, DON, fumonisin, ochratoxin, T2 toxin, zearalenone. In all those cases, vitamin E has a protective effect. Again, protecting against oxidative stress, protective against membrane damages, against actually disactivation of antioxidant enzymes. What about vitamin C, another antioxidant? Again, you can see in the same reviews, they showed that aflatoxin, DON, ochratoxin, T2 toxin, and zearalenone, they also their negative consequences also can be mitigated by using vitamin C. And again, you can see increase in glutathione concentration, glutathione peroxidase, and superoxide dismutase activity, those enzymes which are inactivated by mycotoxins, decreased MDA level, which means decreased lipid peroxidation. And again, in previous slides, you saw that mycotoxins actually negatively affect lipid peroxidation, increase lipid peroxidation, and vitamin C can help you. And finally, the most exciting part, it's polyphenolics. The polyphenolics, there are more than 8,000 compounds in nature. You can see there are flavonoids, flavonols, flavanones, proanthocyanins, and other group of these compounds. And in general terms, polyphenolics received a lot of attention in the last 20 years, and they were considered as important antioxidants. And more and more data accumulated that the action of these polyphenolics is related to those transcription factors I mentioned already. So do we have any evidence that they have protective effect in mycotoxicosis? So if you look at this PEAK study, which is 2019, and you can see here that the activity of catalase, glutathione peroxidase, and superoxide dismutase in duodenum, in the gut, was compromised. You can see a significant decrease. And by adding grapeseed extract, which is a source of polyphenolics, this was reestablished, which means that by using polyphenolics, we can maintain antioxidant defenses in duodenum. The same is true for the liver. You can see here, again, in the liver, the protective effect of polyphenolics is obvious. Another paper, 2019, the effect of polyphenols and vitamin E on antioxidant status and meat quality of broiler chickens fed naturally contaminated with ochratoxin A. Again, you can see here the same parameters, antioxidant enzymes, total antioxidant potential in the blood, in the liver, in breast muscles. And again, ochratoxin compromise those parameters, and polyphenolics and vitamin E actually having protective effect. And in some cases, the protective effect can be in combination even higher than in individual antioxidants. This means that by using these polyphenolics in the diet of chickens, it's possible to maintain antioxidant defenses in the gut. It's the place where actually damage is most important, as I showed you previous slide, for example, leaky gut. At the same time, the gut is responsive for detoxification, and again, to maintain gut integrity, to maintain the microbiota. It's a very important task, and these kind of compounds, dietary compounds, can help. And finally, one more compound called Silimarine, which is a plant extract which is used more than 2,000 years in human medicine. And this is our big review, 2015, which actually described antioxidant properties of Silimarine. And Silimarine is very popular in a way showing antioxidant protection. And in the same at the same time, you can see here that Silimarine actually affect the toxicity of aflatoxin. So you can see here the aflatoxin were used in chickens, and you can see body weight, day 28 and day 35. You can see significant decrease, and by using Silimarine, it was recovered. The same is true for feed conversion ratio. Again, you can see control group, aflatoxin B contaminated group, and protective effect of Silimarine. And again, Silimarine is the most effective compound to maintain antioxidant protection in the gut, to activate transcription factor NRF2, which is responsible for synthesis of antioxidants enzyme, and downregulating NF-kappa B, a transcription factor responsible for the inflammation. One more paper, again, quite recent one, aflatoxin and Peking ducklings affect treatments with lycopene and Silimarine. You can see the protective effect. And finally, what about other botanicals? I came to the end. Yes, the other botanicals can also help to maintain antioxidants defenses, including rosemary, boldo, and others. And one more point, probably the last one, BHT. BHT is commonly used as a feed additive to deal with lipid peroxidation. And in this case, the BHT can also help to deal with mycotoxins. So conclusions. Mycotoxins are major nutritional stress factors in protein production. T2 toxin, DON, zearalenone, ochratoxin, aflatoxin, and funamycin can impose oxidative stress. Oxidative stress is major mechanism of mycotoxin action. And as a result of oxidative stress, we have gut integrity damages, gut microbiota damages, immune system damages, and various organs can be damaged as well. This could lead to decreased productive and reproductive performance. And what antioxidants can do? Dietary antioxidants can help to maintain antioxidant protection in the gut, antioxidant protection in the tissues, and dietary supplementation of dietary antioxidants like selenium, some photogenics or botanicals can help to maintain antioxidant protection and can help to deal with mycotoxin toxicity. And that's my last slide, and I thank you very much for your attention.
Okay, thank you. We can now get started to the question and answer session. We have about 15 minutes for that. Please type your questions on your chat box there. It can be in Portuguese, Spanish, English. We can definitely translate to the moderators. They can answer questions for us. Let me start here with one from Ecuador. The use of polyphenols can reduce the participation of vitamin E on the diet. What would be the recommendation? I'll send that to Dr. Julia Dvorska.
Okay. I think that, well, antioxidants, they are, as Peter showed in his presentation, they're like group or team of antioxidants, different antioxidants, and they all work in different parts of the cells. For example, vitamin E, it works in the cell's membrane to kill or to deactivate the free radicals. But for example, after the activation of free radicals, there is a hydroperoxide, which is also need to be deactivated. In this case, we need superoxide dismutase, so we need selenium for that. And polyphenolic, they are acting in protection of mitochondria, protecting from like keeping the integrity not to produce additional free radicals due to mycotoxin action. So they are protecting mitochondria and decreasing the also production of free radicals. So we need already 3 of them. So I want to say that, just wanted to say that antioxidants, they are working with a team. So we need all of them. It's not enough only to use vitamin E and to support, to maintain physiological needs of the body, and at the same time to deal with the stress condition on oxidative stress due to mycotoxicosis, for example. So in this case, we need all of them for different purposes. So.
Okay, thank you. I will send one to Dr. Olga Verkieva now. What's an acceptable level of zearalenone in raw materials like corn? When a raw material with a high level of mycotoxins is used to mix feed, do these mycotoxins get diluted when a small amount is used in mixed feed?
I get it. It depends, of course, on the country, because there are different acceptable levels in different countries. And are we talking about physiologically acceptable levels or governmentally acceptable levels? Normally, government already issues some guidelines for main raw materials, especially for zearalenone, that will be wheat, maize, soya. And they could be quite high, especially if this grain is intended for the animal use. But if we really see the levels that are allowed or guided for the feed, they are not really correlating with the inclusion rate of this grain. Again, if I go further to physiologically safe levels, they are much lower than normally accepted by government, by FDA or European community, and of course depend on the species. So in case of zearalenone, the most sensitive species are mammals, so ruminants and swine, and less sensitive species are poultry. So I can only refer to some European levels by heart, but still the physiologically safe levels are much lower. And another thing, that if we relate your question to the topic of presentation today, oxidative stress, the good news is that zearalenone is not really a very big problem if we talk about the triggering oxidative stress. So oxidative stress is mainly caused by trichotoxins, aflatoxins, ochratoxins. So if I would pick up just a species that could be a good acceptable levels for swine, I would say if you have 50 microgram per kilogram in the total feed for swine and for ruminants, that is really a safe level. If you go above 100 microgram per kilogram for the total ratio, that could already pose issues in reproductive animals. In poultry, we can go much higher because zearalenone is converted to less estrogenic metabolite.
Thank you. Next one for Dr. Dvorska. What is the best strategy of binders that address mycotoxins directly and additives that support and protect natural antioxidant systems?
Well, when we talk about mycotoxins, first of all, we need to try to eliminate them from the body as much as possible. Like we are trying to bind the mycotoxins which are able to be bound, like aflatoxin, polar, for example, or ergot alkaloids. And then it's good to support the organs like like Peter already mentioned, that mycotoxins goes to the liver, for example, to be deactivated and induce the oxidative stress. So if we can protect, in this case, liver or gut or all the, and also to help antioxidant system to combat this oxidative stress, that will be beneficial. But first of all, we need to try to eliminate mycotoxins and then to support all the organs, including antioxidants, since they are like their levels are decreasing due to mycotoxicosis, and it's not enough to deal with mycotoxins.
Okay, thank you. I will just get another question on this same topic. I'll translate it here. It's in Spanish. What's the best combination or the correct combination of all these different antioxidant products to help with this issue?
Meaning a combination of antioxidants, right?
Yeah, they just said correct of all these different products. So yeah, antioxidants or different ingredients that you can use.
As already mentioned by Peter, selenium can be very good additional solutions when we have anti-mycotoxin products, and then to help antioxidant system to deal with mycotoxins, we can use selenium as a main part of antioxidant defense. Then also, as he mentioned, very popular now, it's polyphenolic compounds from different botanicals like Silimarine or other compounds. They can help to keep integrity of mitochondria and decrease the free radical production by mitochondria due to mycotoxicosis. So again, we can use different combination of botanicals to get polyphenolics. And yes, vitamin E we have already in premixes, so it's no need to increase level of vitamin E since we have already high levels. And could be vitamin C could be added to the diet, especially during the heat stress, but only in this case, not just for mycotoxicosis, for example. Yeah, Guillermo is frozen, I believe. Yeah. Okay. So, yes. Mateus, you can read the questions then.
Yes, let's see other question. And is the oxidative stress the mycotoxin a result of right production of free radical production or a decrease of endogenous antioxidant defense?
It's probably like I can address also this question from the previous one. So when mycotoxin induce oxidative stress, first of all, they are increasing production of free radicals by mitochondria. So, and then at the same time, they are decreasing the antioxidant defense. So both of them, it's the mechanism of mycotoxicosis, of pro-oxidant action of mycotoxins in the cells. So the answer is two of them, both.
Good. And we have other, and I think it's a good question to Olga. Would the standard oxidant levels in feed enough to protect the animals against the oxidative stress if it's already using BHA, BHT, or other antioxidants?
A good and very relevant question. I hear it all the time from the customers. And indeed, that some synthetic antioxidants like BHA, BHT could be taken in vivo, could have a potential benefit against oxidative stress in vivo. But this is not their purpose of the use. And normally, the level of antioxidants like BHA, BHT, I will call them feed antioxidants, is dosed or is chosen according to the oxidative status of the feed. So that means that feed oxidative status will impact on availability of those antioxidants. So they will be consumed by free radicals, which are present in feed. So, of course, if you have excess of BHA and BHT in the feed, it's possible that the body systems, oxidative systems, will take it for themselves for in vivo oxidative stress, but in most cases the level is not enough. It's consumed by feed free radicals already in the feed.
Okay, and we have other interesting question. What type of mycotoxin binders is recommended to minimize mycotoxin exposure and its effects on oxidative stress? What type?
I can, yeah, Yulia?
Okay, you can start then.
Yes, Yulia is our expert in oxidative stress. She has already several publications, and sometimes I would need her help also in answering questions. So the complex mycotoxin binders, or I would say deactivators, would be the best solution. Because oxidative stress is a kind of the consequence of mycotoxins. And even if you use a good binder, which is claiming that they bind high levels of mycotoxins, still in vivo systems, it's not possible to bind 100% of any mycotoxin, even aflatoxins, which is very easy to bind. So always it will be a limitation. Some mycotoxins will escape from binding and will affect the immune system and oxidative systems. And I would strongly recommend not to count only on binders if you would like also to manage mycotoxin issue, including oxidative stress caused by mycotoxins, that the best to use some compounds like Peter mentioned in his presentation, some nutritional strategies to repair and to counteract with negative consequences of those mycotoxins which cannot be bound. So this is a combination of selenium, of vitamin E, vitamin C, sometimes even vitamin A can be involved, and of course the use of some botanical compounds and herbs with proven efficacy to maintain oxidative stress is also quite beneficial. And this is one of the, let's say, cost-effective solutions.
Agree with Olga.
Yeah, and especially now when vitamin prices could go high and sometimes really going very high, that could be effective maybe to adjust a little bit nutritional strategies according to the profitability results.
Yes, and during the stresses, the requirement in antioxidant is increasing, and mycotoxicosis is also oxidative stress, and requirement are higher. So the deactivator of mycotoxins with additional antioxidants would be beneficial in this case, like to increase these requirements or requirements during the stresses.
Okay. Yeah, sorry about that. My internet dropped here for a few minutes. Thanks, Mateus, for taking the lead on for a few minutes. And I will follow up with some questions here. Can animals be experiencing oxidative stress caused by mycotoxins even when they have no clinical signs of mycotoxicosis? One of you two ladies, if you want to answer.
We can answer together. I can start. Yes, animals can be already under the stress, even if we don't see even any clinical signs, because the stress conditions, they're happening on the cells levels, like Peter already showed us, like damaging of membranes of cells, and especially in the target organs for mycotoxins, for example, in the liver, damage of cells in the liver or in the guts. And also it can lead to apoptosis, programmed cell death. It's also one of the mechanisms of pro-oxidant action of mycotoxins. And also in the gut, we can see all the damages from DON, for example, on the cells level. And then we can see the leaky gut or malabsorption syndrome or anything. So even without clinical signs, oxidative stress can be already happening on the cells when we have mycotoxins in the feed.
And I would add from my side that oxidative stress is a beginning of the problem. So when you don't see it yet, doesn't mean that it will not happen. So in fact, when you measure oxidative stress, or you are able to control it or see it at the early stages, you can prevent a lot of diseases which will be a consequence of oxidative stress. So yes, oxidative stress begins first, but often, or I think in all cases, is not really seen by veterinarians or by people who take care of animals. Mm-hmm.
Okay, thank you. I think we are now on top of the hour. It's been an hour that we started. I appreciate the moderators for the question and answers, and I appreciate all our partners in the industry to have joined us today for this webinar. And I hope we can see all you again on May 25th for the final episode on the MycoInfo series. So thank you very much, and please reach out if you have any further questions. We would be glad to answer them. Thank you. Bye bye.
Thank you. Bye.
Thank you. Bye bye.
Bye, obrigado a todos.